Okay, so the AI revolution, it's just exploding, right? But behind all these incredible advances, there's this huge crisis brewing, and it's not in the code, it's in the power cord. So in this explainer, we're going to dive deep into AI's massive and kind of hidden energy problem.
I mean, you see it everywhere. Large language models, generative art. AI is completely reshaping our world. And all that progress, well, it's fueling this insane demand for these huge, power-hungry data centers, the ones built just to train these super complex models. And the scale? It's just staggering. We're talking about a projected 43% compound annual growth rate for these AI training data centers. What that really means is the power they need is just going to keep multiplying, year after year. It's a true exponential curve. So all that explosive growth, it brings up a really critical question. We spend all this time obsessing over algorithms and processing power, but what if the biggest threat, the real bottleneck holding AI back, isn't the code at all, but the power cord? And that brings us right to the heart of the matter, AI's hidden power problem. It's this classic story, right? You've got this lightning-fast exponential demand from the digital world crashing head-on into an electrical grid that was built for a totally different time, a grid that can only grow in a slow, straight line. And this chart right here, wow, it really puts the problem into perspective. So back in 2023, data centers used about 4.4% of all electricity in the US. Now look at the projection for 2028, just a few years from now. That number is expected to jump to 12%. We're talking about nearly tripling in just 5 years. This isn't some far-off problem. This is happening right now. Okay, but here's where things get really interesting. The issue isn't just the total amount of power being used. It's about how AI uses that power. It's not a question of how much. It's all about how fast. So this graph, this really gets to the core of the problem. What you're looking at is the power demand from an AI training data center. And you can see, it's not some smooth, predictable hum. It's just quiet, 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 and then bam! A huge, almost instantaneous spike in power draw the second a training job kicks in. And when you zoom right in on those spikes, you see what are called ramp rates. And they are incredibly steep. The demand for power just changes so violently, in tiny fractions of a second. For the electrical grid, that sudden, massive pull of energy doesn't look like a computer turning on. It looks like an entire power plant just suddenly went offline. It's a shock to the system. Let's actually put a number on that violence. In some cases, the rate of that change is 1.9 per unit per second. Now, to put that in plain English, that means the data center's power demand can nearly double in just 1 second. Our electrical grid just isn't built to handle that kind of jolt. And the consequences of this? Oh, they are very, very real. Power companies, the utilities, they see this insane instability and they're just slamming on the brakes. We're now seeing delays that are years long just to connect a new data center to the grid. They're demanding these incredibly expensive upgrades to the infrastructure. And all of this is creating a massive bottleneck for the entire AI industry. So if the whole problem is shock, what's the solution? Well, a shock absorber. We're talking about a purpose-built shock absorber for the digital age, something designed to sit right in between the chaotic demands of AI and the, frankly, fragile stability of the grid. And this is where a very specific technology enters the picture: lithium-titanate oxide battery systems, or LTO for short. Companies out there like Dynamic Grid are engineering these systems for this exact challenge, to handle the unique stress that AI data centers put on the grid. So, why LTO? What makes it so special? Well, this chart here tells the whole story. There are a couple things here that just jump right off the page. First, look at that charge and discharge rate. At over 5C, it can suck in and spit out energy incredibly fast, which is perfect for handling those crazy sub-second spikes we were just talking about. But then there's the second thing, the cycle life. And this is what really sets it apart. Over 20,000 cycles. That is 3 to 5 times more durable than the other common battery types out there. Think about it. For a data center that has to deal with these spikes constantly, day in and day out, that kind of durability is an absolute game changer, both for reliability and for the long-term cost. So you can basically think of this LTO system as an intelligence layer. It's this really smart, ultra-fast buffer so the data center can pull power as erratically as it wants. And the LTO system just smooths everything out so the grid never even feels that shock. It completely decouples the two. So the data center gets the flexibility it needs and the grid gets the stability it needs. Everybody wins.
And this is where things get really fascinating. Because by solving this power problem, you're not just getting rid of a risk. You are actually turning what used to be a huge liability, your power bill, into a high-performance strategic asset.
And the benefits? They're huge. So you can basically go to the utility company and say, hey, don't worry about us. We'll handle our own power spikes. And just like that, you can get much faster approvals to connect to the grid. You can put off spending millions on grid upgrades. You can avoid having to shut down your computations. And get this, you can even start selling services back to the grid, which creates a whole new way to make money.
This slide really sums up the whole transformation. You go from being grid-dependent, where you're stuck in these long delays and you're basically just a stress on the system, to being grid-interactive. You actually become a partner with the utility. You're helping to stabilize the grid instead of constantly disrupting it.
And, of course, the financial side of this is just as compelling. When you add it all up, the money you save, the downtime you avoid, the new revenue you can generate, the annualized ROI for these LTO systems can be more than 15%. So this isn't just a clever engineering fix, it's a really powerful business decision.
So what does all of this mean for the future? Well, what we're really talking about here is completely redefining the relationship between computing and energy. It's about building a smarter power infrastructure so we can enable even smarter AI. And that really brings us to the key takeaway of this whole thing. The next generation of data centers, the next big leap for AI itself, it's not just going to be about shoving more processors into a box. No, it's going to be defined by power intelligence, the ability to manage, to shape, and to optimize every single watt of energy. Which leaves us with one final, pretty critical question. Look, we know the future of AI depends on a grid that's smarter, more responsive, and more flexible. The technology to build that grid, it's already here. The real question is, are we ready to build it?